Good afternoon. My name is David Boyer. I am the Central Regional Sales Manager for Hendrix Aero Cable Systems. I will serve as your host for today's session, exploring the differences between spacer cable, tree wire, and bare wire overhead distribution systems. This is the fourth in a series of 5 webinars Hendrix is conducting between now and the end of the year. This webinar will compare the differences in construction, components, and best suited applications of each of these overhead circuit types. As to our format, today we'll begin with a 40 to 45 minute PowerPoint presentation, followed by another 45 minutes of Q&A for a total of 90 minutes. Most of you are already familiar with the Q&A tab appearing at the bottom of your screen. Anytime during the presentation, use this tab to submit your questions. I'll be screening the questions as they come in and will relay some of the questions to our presenter during the presentation. At the end of the presentation, we'll address all other questions submitted in the Q&A segment. Now that I've covered the format formalities, let me introduce today's presenter, Mr. Brian Traeger. Brian serves as the Director of Technology and International at Hendrix Aero Cable Systems. Brian holds master's degrees in both electrical power engineering and business administration. Brian is a longtime member of IEEE, where he has authored over 50 papers. In his 40-year career, he's held various engineering, consulting, and management positions at AEP, Cooper Power, and Fisher Pierce. We have been fortunate to have Brian as a colleague for the last 26 years. So without further ado, the floor is yours, Brian.
Great. Thank you very much for that introduction, Dave. And good afternoon to our webinar participants. Thanks for taking time out of your busy schedule to be with us here today for the continuation of our webinar series. So fantastic. Let's get going. Again, the topic today is spacer cable versus tree wire versus bare wire on overhead distribution systems, mostly medium voltage distribution, but this extends to transmission voltages as well. So we put together, as far as our outline, introduction, definitions. I'm going to tell you what bare wire, true wire, and spacer cable are. I'm going to torture you a little bit, a couple of slides on theory of operation, since we, for the folks that are just tuning in now, don't know how it works, we'll cover that briefly. And then the rest of our webinar is going to talk about comparisons, differences, pros and cons, and we tried to break this down to as many component parts as we could, talk about cable construction, what the configuration is, respect to tree trimming, maintenance, costing, bird and animal contact, maybe look a little bit into harsh weather performance. It was suggested that we throw wildfire mitigation in, construction challenges, and quality of services, and see if we can come up with any conclusions there about our own situation. Quick intro, I kept the 1960s catalog photo in there. So we've been around since 1951. We've got almost 70 years in this business with 5, 15, 25, 35, 46 kV. We're in 69 kV since the 90s. We've been in 115 kV. We have that in pilot. That's been for over a year, so we're excited about that. We're in all 7 continents, over 75 countries. We have continuous R&D, continuous improvement, and we're for reliability, economics, safety, and again, we say that spacer cable or covered wire is a design option. We don't recommend that it's used everywhere, but it is certainly an option when we are faced with construction challenges or other operational challenges that we need to find solutions for that we don't quite have. So we'll start off, spacer cable is heavily covered non-shielded phase conductors held together and supported by a high strength messenger. Okay, you can see the messenger up there. That has several functions. It's the mechanical support member, it's your shield wire, it's your system neutral, and it's your mechanical protector. It holds things off the phase conductors that may fall from above. We've got spacers every 30 feet, every 10 meters, a couple of brackets, tangent bracket, dead end bracket, angle bracket, but it's a very simple system. And for those of you who have watched me make these presentations before, we always talk about what standards. National Electric Safety Code covers it for 49 out of the 50 states in the US. They say covered conductor shall be considered bare for all clearance requirements except that spacing between the conductors. And there's a few caveats, but we can reduce the phase-to-phase spacing quite small, and we can reduce the circuit-to-circuit phasing. So that's covered by NESC 230D. CSA struggled for years to get us in CSA. We finally did that at the end of last year, and I believe the Canadians are doing a good job. They're being quite deliberate in the writing of their specs, and they're saying that covered conductors swing in the wind more than bare conductors due to the larger surface area, but are protected from brush contact with vegetation, and therefore reduced clearances should be permitted. So, and then we have the ICEA, S121-733 came out in 2016 for the standard for tree wire and messenger supported spacer cable. And again, so this does not apply to systems, it only applies to cable. So it applies to materials, constructions, and testing of tree wire and messenger supported spacer cable. And it obviously is going to cover both the thermoplastic and XLPE rated for 75C or 90C normal surface temperature. And this ICEA, even though it is for a component and not a system, they were prescient enough to add a cautionary note to ensure dielectric compatibility in selecting components, which means don't use porcelain insulators, don't use porcelain spacers because you're going to ruin your cable. So that was quite nicely done on the part of ICEA. Okay, I got a couple of slides for theory, and then we'll get right into the meat and potatoes of the presentation. So we have bare wire. What we're doing is we're using essentially air as the electrical insulation, and air is okay as an insulator, but you need a lot of it. So we need a large separation in between those individual phase conductors to prevent phase-to-phase contact and conductor clashing. But it's still subject to outages due to contact with trees and animals. So what we do is we put a little bit of polyethylene on those phase conductors, and that poly replaces the air, and it allows us to bring those phase conductors very close together, almost touching, if you will, and it's going to give us a high 60 hertz withstand. It's going to give us a high impulse strength, and that cable will withstand short-term phase-to-phase contact, phase-to-ground contact, phase-to-animal contact, if you will, without having a concern for faulting. Our design objectives is to keep that contact current, or the current that we would feel if you actually touched it or short-circuited the outside jacket. You would keep that down to about 1/3 of a milliamp at 15 kV. And of course, that depends on the size, the kV class, how much surface area you have, etc. But basically 1/3 of a milliamp. And that's going to allow momentary contact without an outage. And I say down here that control of surface charging current is the key to essentially everything. We want to prevent tracking. We want to minimize safety issues. We don't want to trip any breakers or fuses if we get a contact or a long-term contact, but also equally importantly, with that 1/3 of a milliamp swimming around on the outside of that jacket, we want to maintain insulation integrity over the useful service life of this conductor. Okay, so we want that as good after 50, 60, 70 years as it was the day it was installed. So that is the key to controlling surface charging current and deciding how thick that insulation wall really has to be. We've got a 3-layer insulation system. The semicon shield is the same reason why we use a semicon shield in underground cable. We essentially want to fill the on top of the individual strands, which may have mechanical sharp objects on them, and we also want to fill the interstices between those individual phases. So if we get a contact with the ground and we have 100% of the line to neutral voltage across that very tiny insulation wall, we won't have a very intense electric field that would be presented if we didn't have that semicon shield. The semicon shield puts all points on the circumference of that bare wire at the same voltage, smooths out the electric field, minimizes partial discharge, gives us a higher BIL and a longer useful service life. The inner dielectric is, as you see there, it's the second layer. It's basically translucent. You can shine light through it. It's going to be a very high molecular weight, low density polyethylene. There are no fillers in it whatsoever. We want to maximize our BIL and our 60 Hertz withstand, but we also want to have a very soft inner layer for stripping. We will put a spiral knife into the outer jacket and penetrate most of the inner jacket and turn it in a spiral fashion. And that inner layer will be easy to strip and it will peel off the semicon layer at the same time. So it's a multi-function. The outer jacket, on the other hand, is where we put a lot of the tricks in. That outer jacket is going to be a high density polyethylene and essentially the highest density polyethylene that we can source, because there is the anticipation that at some point in time that will come in contact with a tree, and we want to have a very, very, very high abrasion resistance, and that high density polyethylene will give us the high abrasion resistance. It is also where we put our track resistant adder and also where we put our UV inhibitor, and that UV inhibitor is a chemical UV inhibitor. It's going to put a chemical umbrella on top of the molecular chains and protect them from UV radiation. And that's different than the carbon black that some manufacturers are adding that's fugitive and oxidizes, has all kinds of problems. But anyway, that's a 3-layer construction. And of course, due to Ohm's law, if we want to control the charge and current on the surface at higher voltages, we need more resistance, right? So we need more insulation. So we'd start off at 15 kV with 75 plus 75. That's about 150 mils of insulation, which translates to about 3.8 millimeters. Where we get up to 69 kV, we have 250 plus 250. It was 500 mils, or 1/2 of an inch, or approximately 12.5 millimeters. So we'll get into the definitions. We'll pass the theory, we'll pass the standards. Well, everybody knows what bare wire. Yes.
Brian, we had a question. Want to make sure that we clarify that this is not a fully insulated conductor and needs to be treated as bare wire according to ASC. Is that correct?
That is absolutely positively correct. National Electric Safety Code Rule 230D tells us that if there is not a concentric neutral on that jacket, it is not, that cable is not insulated, it is covered. So that's the difference between covered wire and insulated wire. It's covered and we have to treat it like bare wire for all clearances, except clearance to edifice clearances, and we'll talk about that later, and safety and work practices.
Okay.
So bare wire. We usually use ACSR, AAAC. It's on cross arms, good old pin type insulators. It's simple, it's the lowest cost, at least for single circuit. Clients definitely generally accept this, and it's our standard, it's our national standard. But it is subject to outages from trees, from wildlife, and from conductor clashing. When we move the tree wire, now we're just changing out that bare wire to heavily covered conductor. That's going to use the 3-layer design that we talked about. And the construction is going to be using standard or shortened cross arms or armless brackets. And this is what it looks like. It looks a lot like bare wire, right? Except it's covered. We got to use poly insulators. And there's a couple of other construction changes that we'll try to delineate as we proceed through this presentation. Spacer cable, we already told you what that is. 3 heavily covered conductors hung by a messenger on spacers. And let's not forget our single phase spacer, which is highly utilized, seldom seen, but highly utilized in backlot construction and areas that are close to trees that don't want to be cut. Great. So let's start at the beginning. Let's start comparing bare wire, tree wire, and spacer cable with cable construction. Bare wire, we're usually using ACSR, triple AC, sometimes double AC. Tree wire is almost always ACSR or triple AC because it's self-supported. It's fully under tension. Spacer cable, there is no tension in the phase conductors. They're basically hung up on the spacers and connected to the messenger, not that much different than you would put a shirt on a hanger and hang it up on your closet. There's no tension on those phase conductors, so we don't need rated tensile strength for spacer cable. So we're always using all aluminum conductor. I can compact it, which gives me a smaller diameter. I'm losing less polyethylene, which is costly. With the smaller diameter, I'm going to have a lower physical profile, and it's going to have lower wind and ice loading, which is going to be good for the poles and the guys. I'm going to have a higher ampacity, a lower cost. There's all kinds of advantages using double AC as your medium voltage conductor with spacer cable. Talk about insulation. Well, in bare wire, we don't have any. Tree wire and spacer cable, I'm using the exact same 3-layer construction. There is absolutely no difference between tree wire and spacer cable when I talk about the insulation construction. A couple of caveats is, well, with tree wire, we have 1 or 2 clients that possible use of all aluminum conductor. It depends on the size, our rated tensile strength, span length, loading, and all that good stuff. That's obviously going to be for a heavy conductor, 336, 477 or higher. Whereas spacer cable, where we always use double AC, we have a couple of customers that use ACSR for spacer cable as well. And sure, it's mechanically viable. I don't need that rated tensile strength. I'm not desirous of the reduction in ampacity. It's not economical. It's not beneficial from an ampacity standpoint, but it may be beneficial from a stocking standpoint. The line crews can leave the the lay down yard with their reels of cable and not worry about making a mistake of pulling out ACSR or triple AC for one or the other. Mechanical configuration, bare wire, I'm always on a cross arm. Tree wire, I'm always on a cross arm or a compact bracket. Remember, I can reduce the phase spacing. I don't have to worry about conductor clashing, where spacer cable is always on a compact bracket. When I talk about dead ends, bare wire, sure, I'm using full tension clamps, 100%. Tree wire, it's under full tension. So I need full tension dead end grips or shoes. Where with spacer cable, there is no tension, so I'm using partial tension preform grips. And the reality of that is that when I use tree wire, so therefore with full tension clamps, I'd require stripping where those dead end clamps are. So the benefits of a covered conductor system are lost at the dead end poles or the double dead end poles. Whereas with spacer cable, I'm using preform grips over the covering and the system remains covered absolutely everywhere. When I talk about the physical profile, bare wire obviously requires more right of way and exposed to fauna and flora, always. With tree wire, without the messenger, there's only so much compaction that can be achieved. But it can be compact, but not as compact as spacer cable. And it's also vulnerable to overhead trees. I could have a tree come down and lay across the 3-phase conductors, cause abrasion. I could have a tree come down at the stripped point at the dead end, cause an outage. So there's a couple of issues there. With spacer cable, I'm always compact, and the phase conductors are always protected by the messenger. Let's take a brief look at tree trimming and maintenance. And I've showed these specs before. This is from a local utility, EverSource, and they've got all kinds of specs here, and I'm sure every utility does. For routine maintenance, they want 15 feet above the conductor, 8 feet on the side, 10 feet below. For enhanced tree work, they just want to make sure they've got 8 feet between a conductor and the tree. And for routine maintenance tree work, they don't want 15 feet, they want 20 feet above and 8 feet on the side. So, you know, what do those specifications get us? Essentially, for bare wire lines, extreme measures are sometimes required to meet the specs and to save the tree. It doesn't really look like they're saving the tree, but I guess the tree is still alive, so they saved it. As you can see from these photos, and these are 3 photos of thousands of photos, it results in the loss of aesthetics, and the tree is still at risk of contacting the power line and creating an outage. If we take a look on the left, we have conventional bare wire or tree wire. So yeah, I need that 6 feet on the side, 15, 20 feet on the top for bare wire or tree wire. If I look at my drawing on the right, what I've done is I've taken that cross arm off. I've put a compact bracket on the street side, not the load side. So automatically I've saved 6 to 8 plus 3 plus 1. So I've saved 11, 12, 13 feet on the side of that tree. If you take a look at on top, I no longer have to remove those branches because if they get wet and come down, they will sit on the messenger. And that messenger is made to handle that. Number one, it has a very high rated tensile strength, so it can handle a mechanical load. And number two, it's grounded every 500 feet or less, so it can also handle that electrically. So here we have the same artwork on the left, conventional bare wire tree wire with the routinely massacred foliage. And on the right side, we have a spacer cable system fitting through a nice clean tunnel. So to summarize, tree trimming for bare wire requires full attention and short trim cycles to keep the lines from the foliage, but it's still at risk of contact and fault in the high winds. With tree wire, while intermittent contact is okay, we're still at risk of branches falling across the phases and risking insulation abrasion. Spacer cable, I'm saving 80% of the canopy, I'm saving 80% of the tree trimming, intermittent contact is fine, and I can maintain the same clearances, which means as far as maintenance with bare wire, yeah, bare wire maintenance is periodic, it's easier to spot trouble. Tree wire, you know, we'd recommend annual or inspections after big storms. Again, concern is trees and or branches lying atop the phase conductors. We want to maintain some spare parts. And spacer cable was saying periodic, again, annual and or after big storms, we want inspections. It's going to require very minimal maintenance, and maintaining spare parts is always a good idea. Costs. I've been developing this chart for years, and recent activity by my upper management has since made this chart obsolete. So what we want to do is compare bare wire, tree wire, and spacer cable on material, labor, tree trim, site prep, and maintenance. So I said, well, material, you know, bare wire is 1x, tree wire is going to be 20, 25, 30% premium in materials, where spacer cable can go even higher, especially at higher voltage levels. Labor costs, we're saying, you know, maybe a 10% premium for tree wire over bare wire. Spacer cable might be a bit more. And then other numbers for tree trimming, site prep, and maintenance. But we're going to show you at the end of the presentation what we call the value calculator that is going to be able to make all of these calculations and doing a return on investment business case for you. We're asked years ago to comment on energy savings. Well, what is the difference? Well, if I took a look at energy, as far as voltage regulation, the energy savings I'm going to get from losses as a function of voltage regulator for bare wire, I've got none, right? I've got bare wire. For tree wire, I don't have any reduction in phase spacing, so I'm going to have the same impedance and the same voltage regulation as bare wire. But with spacer cable, due to the fact that my phases are close together, I have a 15 to 20% reduction in impedance, a 15 to 20% reduction in end-of-line voltage, and top-of-line head of feeder voltage. I'm not cranking up that voltage and the current to compensate for that increased impedance. So I have lower losses there. Let's talk about leakage. With bare wire, there's no savings. It's as leaky as can be. For tree wire, since I have covered conductors, again, we're keeping the leakage current at the outer jacket to 1/3 of a milliamp. So I'm having lower losses since the conductors are not releasing leakage current to the tree's insulators, except at the bare spots for tree wire. With spacer cable, there are no bare spots. So it's the best scenario, negligible leakage, no bare spots. How about the carbon footprint? I didn't put a number here, but bare wire is obviously extremely poor. With tree wire, I have more trees and foliage, and that relates to cleaner air through absorption of carbon monoxide and other pollutants. And with spacer cable, still more. It's the best scenario. Even more trees and foliage relates to cleaner air through absorption of carbon monoxide and other pollutants. Bird and animal contact, we'll go through this quickly. All utility people have got dozens, if not hundreds of photos. Bare wire and Mother Nature do not go together well. It seems that nature is attracted to our power lines, and often with very unpleasant results. Bare wire is always vulnerable to animal-related outages, conductor clashing, wind, lightning storms, etc. There's a lot of animals we've lost along the way with bare wire. How about tree wire? Well, tree wire is a heck of an improvement over bare wire, but we still have a vulnerability to component selection errors that some users think that you just change out the bare wire for covered wire and boom, you're good to go. But it's a little bit more complicated than that. You have to think in terms of systems. So with tree wire, there's a tendency to use the wrong components, whether porcelain insulators or the wrong shoes or the wrong type of stripping. And it's a safety hazard to birds and climbing animals. And this picture is quite cute, but it may not have a good ending. If we take a look at spacer cable, it's completely covered, and it eliminates safety hazard. It's APLIC compliant, and it's ideal for national parks, for wildlife areas where we have climbing animals, where we have waterfowl and migration habitats. So it's used a lot in those areas. And I have another photo here. We got eagles and animals that climb on power lines, and sloths and anteaters, and there's a whole bunch of other animals, but these are just some of the better pictures that we have. So bare wire has a high vulnerability to bird animal contact. Tree wire, it's only vulnerable at the strip points, the dead ends, and spacer cable is extremely low vulnerability. Take a quick look at harsh weather performance. Bare wire. If bare wire is not rigorously storm hardened, it will not perform well in harsh weather. And we see this every year, whether it's ice storms, hurricanes, tornadoes, summer events, winter events. Tree wire provides temporary fall protection. It's resilient to small tree limbs. However, branches, again, may lie across that conductor, eventually causing abrasion. Fallen trees or large branches can possibly knock the system to the ground, resulting in an outage, and possibly the conductor would break before the pole. Some see that as an advantage of tree wire and harsh weather performance. Spacer cable is a more robust design intended for extreme weather due to the mechanics of that design. The overhead messenger is going to protect those phase conductors from trees and branches, fallen trees, and keep them from causing outages. Usually a fallen tree is going to be supported by the messenger, and a large impact may cause that pole to break. But again, the line's going to stay energized, which is what we want. We also have a significant resilience to seacoast contamination, as well as other forms of contamination. And possibly at some point, we'll have a webinar on this topic. And tornadoes. So there's a 2015 tornado in Boston. Everything was on the ground except the spacer cable. Our famous Pepco line photo. This is, I don't think this was from harsh weather, but it's certainly a good photo. It fell down, got it on a helicopter patrol. It was up there a couple of weeks, couple of months, but no damage, no outage, and fantastic operation. And here's our spacer cable in Banff National Park. I always say this is the best photo we've got. This is Northern Rockies. Line crews go in here as soon as they can in the spring or the summer, and you can see in this single span, there's 1, 2, 3 trees lying on that messenger, and they went essentially the whole winter without an outage. So this is reliability and harsh weather performance. And one of our clients in Latin America, that's a rather significant tree that was held up by a single phase line, amazingly. And of course, we would not be complete if we didn't include our Antarctica, McMurdo Bay. There's one medium voltage system on all of Antarctica, and that is spacer cable. You can see that. So in summary, bare wire is prone to outages from high winds, ice storms. Tree wire is good, and spacer cable has the highest resiliency possible, resistant to winds, ice, hurricanes, and tornadoes. I wanted to take the opportunity to throw in a study, and I came across this recently. This is a study we participated in about 21 years ago. So EA Technologies is or was the field research lab for the British Isles, and because all the utilities were government owned, right? So this study was commissioned by the UK utilities. In '99, there were 14 of them, and that included England, Wales, Scotland, and Northern Ireland. So they went to this research center called Deadwater Fells. It's a severe weather site. It's on the UK Scottish border up by Hadrian's Wall. It's at 1,900 foot elevation. It's 50 miles east and 50 miles west of the North and Irish Seas. As you stand up at this site, you can look to your left and see the North Sea. You can look to the right and see the Irish Sea. And it's exposed to severe wind and weather from all directions. So the objectives of this study, what the UK utilities wanted to know is, what is the difference between bare wire, tree wire, and spacer cable in severely harsh weather conditions? And they had this thing instrumented, temp, wind speed, direction, pressure, humidity, tension, vibrations, and they had high-speed cameras everywhere. Very impressive research center. And without going through that report, I'll give you a couple of conclusions. So they took a look at the effect of wind on conductors, wind only. They separated out the snow or ice, and they said tree wire, which is identified here as BLX. A couple of decades ago, tree wire was called BLX in Europe because of the Scandinavians mostly introduced it in Europe. I should say 30 or 40 years after Hendrix, but they were still the ones that introduced it after us. So tree wire is always affected worse by the wind, which I guess was kind of surprising to the researchers, but they explained it by saying tree wire has the largest size to weight ratio. And they further found out that spacer cable always exhibits the lowest increase in load with harsh weather, with high winds, which was good news for the poles and the guys. And the bare wire was closer to spacer cable, but essentially somewhere in the middle, pretty good. Then they took a look at snow and ice on the conductors, and ice loading is significant in the British Isles for reasons we could get into later. But they said tree wire is always affected the worst by the snow and ice. And spacer cable is always the best performer. And bare wire performs pretty well, but not as well as spacer cable. And the British researchers came to a couple of conclusions, and instead of paraphrasing them, I put them here verbatim. And they said, these graphs have tried to summarize the data in simple graphical form. However, looking at the data, generally, some conclusions can be drawn. The Hendrix Spacer cable has performed extremely well in severe conditions. It has had to withstand wind gusts of hurricane force as well as severe snow and ice incidents. In comparison with single sheath covered conductor or tree wire, the Hendrix Spacer cable has accreted less snow and ice and suffered less from wind loads, especially as the weather conditions got worse. In comparison with bare wire, the Hendrix Spacer cable has generally performed better under all scenarios. So that was a great study. We thank you to EA Technologies for carrying that out, and that was good fun. I was asked to include wildfire mitigation, and what I wanted to stress here is what are the differences between bare wire, tree wire, and spacer cable with respect to wildfire mitigation, and not wildfire survival, but wildfire mitigation, as in mitigating the risk of a power line igniting a wildfire. So we went through with this some utilities on the West Coast, and basically we're going to use tree wire when there are no trees. And that may sound crazy, but why would I use tree wire if there are no trees? Because there's still a concern for flying palm fronds. So apparently palm fronds can get ignited and fly for up to 2 miles. And these palm fronds are not small. They can be up to a couple of feet long. We've got to remember that fire is an ionic plasma. So we want to avoid getting it between the phases and causing a flashover. And in wildfire mitigation areas, we're going to use spacer cable where there's trees, where there's reduced right of way, multiple circuits, and so forth. So with respect to wildfire mitigation, bare wire gives you no mitigation whatsoever, whether you got wind, swayed trees, fallen conductors, sparks all over the place, and serious sources of wildfire ignition. Tree wire is good when there's no trees, because I have a concern for airborne ignited palm fronds, and concern for that flashover is eliminated. Where spacer cable, intermittent tree contact is possible. If a line down, there's no sparks, no ignition, and it's a viable wildfire mitigation strategy. Go through a couple of more construction challenges. With bare wire, we're talking about reduced right of way. Bare wire, I need 12.5 feet above the roof line. A tree wire, the same. Where with spacer cable, National Electric Safety Code said I can reduce my clearances by 2 feet. So let me just show you a quick picture without trying to read through National Electric Safety Code. You can see in this space, we've got a 14-foot alley. We're going from a 5 to a 15 kV upgrade. There is no room for bare wire to meet National Electric Safety Code. But with the NESC rule change, they say we only need 5.5 feet. Now I have a tunnel in the middle of that alley where I can install spacer cable. So this is before, we've done a lot of projects that cities that have alleyway construction. So here's the 5 kV and here's the 15 kV upgrade. So it's a clean, safe and economical solution for reduced right-of-way construction. Here's a client that did it at a slightly larger alleyway, and they did it with tree wire. This is not the US, this is outside the US, but it's a pretty nice looking job. And we have a lot of projects here. We did a substation exit with spacer cable, and instead of going 3/4 of a mile around all the streets, they just jumped through 2 alleyways and saved a small fortune on this project. How about long spans? Well, bare wire requires significant phase spacing. And for spans greater than 500-600 feet, I often require 3 poles. Tree wire, long crossings have a weight issue. I require heavier poles. But there's certainly benefits with tree wire compared to bare wire, since if I have conductor clashing, it's no longer an issue. With spacer cable, all the strength is in the messenger. There's no limit to crossing length. And the longer the crossing, the greater the benefit of spacer cable compared to tree wire. So here shows a relatively short crossing. This is only 600 feet, but it's a double circuit highway crossing, relatively not that tall poles, very nice looking, efficient job. Some states have most of their highway crossings as spacer cable. And here's a longer job. So there's going to be 1,600 foot crossing. This is during construction, obviously. So the submarine cable was going to cost about $1 million. Building around the shoreline, 800,000 using spacer cable, 75 grand just for a single span and a couple of poles. So they saved, $725 to $925,000 by going spacer cable on this job. And of course, it's also viable for multiple circuits, as you see here. This is Edmonton, New Brunswick. How about multiple circuits? Well, when we talk about bare wire, we're basically generally limited to 2 circuits per pole. When we go to tree wire, theoretically, there's no limit, but more than 2 circuits, it starts getting a little bit crowded. When we talk about spacer cable with multiple circuits, there is no limit. So here's a famous wind farm with our Canadian neighbors, and they erroneously built this with bare wire. You can see what 2 or 3 circuits on a pole looks like, and this was good until the first storm, and then it was all on the ground. I don't know what it looks like today. Here's spacer cable with multiple circuits. There are no limits. We have circuits with, we have poles with 8, 9, 10 circuits on a pole. It's extremely convenient. And we can also have underbuilds. So here we have a 69 kV circuit on the top with a 25 kV on the bottom, and that's not uncommon. So reduced right of way. Bare wire is difficult at best. Tree wire is more compact. Spacer cable is extremely compact and an ideal application. Long spans, spacer cable is really the only compact system that's going to avoid requiring 3 poles. Multiple circuits. Bare wire is dead in the water. I mean, you've got 2 to a circuit. After that, 2 circuits to a pole. After that, lineman won't work on it. Tree wire, theoretically 2 to 3 circuits per pole. Spacer cable, no limit of circuits on the pole. For storm hardening, we say, well, for bare wire, storm hardening for bare wire is difficult. There are very few options. We can use the standard options: increase pole class, use fault circuit indicators, loops, feeds, smart grid. But again, don't build your system on a house of cards. Don't build your smart grid on a house of cards. If your system is weak, it's going to be weak even if you're reporting it with smart grid. Tree wire is better than bare wire. The weak link is the conductor, insulator, and the pole. Spacer cable is intrinsically hardened already. Multiple design options to increase the hardening include using a heavier messenger, heavier pole, or a combination. Quality of service, bare wire and tree wire have no improved voltage regulation. Spacer cable, the closeness of the faces reduces the mutual inductance. The total impedance is reduced by 15 to 20%. The reduced voltage drop by 15 to 20% reduces the need for our switch cap banks voltage regulators. We're going to have a better end-of-line voltage on voltage limited feeders, and as well a higher power factor. Restoration time, well, bare wire is one up on this. Bare wire is the fastest restoration time, so kudos there. Tree wire, faster restoration time for faults involving pole failures. Spacer cable, it's going to take longer than the other two, but we're using spacer cable because it is intrinsically robust and is going to reduce the number of line down events. How about the quality of service? Bare wire, inherently poor. Tree wire is favorable. Spacer cable is far superior with a safety, SAIDI, and CAIDI reliability indices. We're going to have reduced outages, reduced loss of revenue, reduced trouble crews, and greater regulatory compliance. People used to say, hey, what is the cost of reliability? Well, cost of reliability is sending crews on Saturday night to find the faults, lost revenue from the feeder being out, bad public relations, public utility, SAIDI, safety, CAIDI, reliability indice penalties, loss of industrial load, inability to attract industry, and loss of critical roads, whether that's hospital data centers or what have you, and future rate hike denials by the Public Utility Commission. And we can have cost versus reliability in a nice graph, even though this is conceptual, it's not necessarily empirical. So here is our matrix on voltage regulation. This data can be made available after the seminar. Voltage regulation, only spacer cable has a 15 to 20% improvement. Bare wire, surge protection depends on the adequacy of the over voltage protection. What do your arresters look like? How are your grounds? Tree wire, potentially worse than bare wire because I got stripped dead ends. Spacer cable, it's excellent surge protection. Have high BIL, and the open points have arresters. Restoration time, we said bare wire was the fastest. Reliability indices go from poor to better to extremely high when you go from tree wire, bare wire to tree wire, the spacer cable. So I alluded to this previously, and we have clients say that they're, we're convinced we want to use spacer cable. We're interested in using it, but it's too darn expensive. So their objection, or the objection often posed, is the higher CapEx or first cost of spacer cable when we compare it to overhead. And as I showed you in slides previously, the material costs can be 20, 30, perhaps even 50% higher than bare wire, depending on the voltage class. So it's kind of hard to get it past management or the purchasing department. But a long-term financial analysis demonstrates a complete return on investment, usually under 2 years. So this new value calculator tool that my management is bringing out does return on investment comparative business case scenarios customized to the project scope, not only the project scope, but the application. So you can contact somebody at Hendrix and we can work through any scenarios you are thinking about. And I don't want to go through all this, but this is what it's going to look like. A couple of pages overlooked. You can take a look at your application, whether you got trees, environment, wildfire mitigation, multiple circuits, line location, whether it's rural or urban, and that's going to affect, installation costs, crew costs, type of circuit, whether it's new, single, double, what have you, what you're comparing it to, bare wire, tree wire, underground wire. Currency, I think we're going to have US and Canadian. At some point, we'll hopefully have other denominations in here. But it's going to give you, and then you have to enter the circuit length and your cost of tree trimming per mile, or years between tree trimming, a cycle, et cetera, et cetera, et cetera. And it will give you the, the repair cost savings, the regulatory penalties, avoided revenue loss, tree trimming savings cost, inspection savings cost, installation savings value. So this is very valuable, and hopefully we'll go through this. And not only that, but it will do, again, as I said, a return on investment comparison between spacer and bare, spacer and tree wire, spacer and underground, and the applications it will look at will be for heavily treated areas, multiple circuits, additional circuits, over and under builds, substation getaways, limited right of way, and wildfire mitigation. And we will have one more webinar in our series. and that's going to be held off till December 8th, and that's going to be when traditional overhead construction is not an option. And we're going to try to look at when traditional overhead and underground distribution construction is not an option, and why these individual clients went with spacer cable. This will be a case study based webinar where we're going to try to go around of all of our geographic regions of the US and Canada. I'll try to pick some foreign applications, and we'll try to pick some industrial applications, and you can get just an idea of the whole spectrum of when traditional construction is not an option. And with that, I will turn it back to our moderator, Mr. David Boyer, and he will be able to, I think, field questions if there are any. Thank you very much for your time.
Brian, thank you. Great job. Yeah, we've got a few questions here. The first one is pertaining to working clearances. Reduction on each type of the material that you just went over. The question is related to the fact that their crews are performing live work, and their understanding is they need to treat this as bare, which is true, for safety reasons. So how would they go about that, and what changes with spacer cable and bare and tree wire?
Okay, very good question. So the first thing I have to say is National Electric Safety Code says that if there's not a concentric neutral on it, it must be treated as bare wire for all safety and work method and work methods. So their MAD, their minimum approach distance, cannot change. So how are they going to work it with work methods? Basically, with some modifications, while still respecting National Electric Safety Code Rule 230D, and while respecting 100% of the safety and work method regulations of their individual utilities. If they can gin up, if they can work up new work methods that allow faster, more reliable, safer work methods while working spacer cable, while still respecting National Electric Safety Code and their own utility standards, then that's fantastic. Otherwise, they have to maintain all of those distances. We're not saying you can take any shortcuts with spacer cable or tree wire. And as far as how people are being more efficient, we've seen utilities here in the New England area, in other areas, that work on it hot every day, and they know how to do it. And whether they are reducing their MADs or not, I am not certain. I'm not a lineman, but yes.
Yeah, we can definitely follow up, Brian, with that. I have the person's name that asked us, and we can have either a regional sales manager reach out to you, or have one of our field service reps talk to you about maybe some different practices that they found that makes it easier to work on spacer cable or tree wire and still stay within your safety recommendations. So the next question, Brian, two of these actually kind of pertain to, if cover conductor is on the ground and it stays energized, would that potentially present a public safety hazard? Since it's covered, the public first responders may think it's insulated and okay to touch it. And so what would happen if someone touched an energized covered conductor?
Yeah, good point. Okay, so this is something we've gone and done a lot of research on. This is something we published in the IEEE, that we presented at various conferences. What is the contact potential, and what is the contact current? So we all know that, you can touch anything you want, no matter how high the voltage, as long as you're not grounded, you're going to be fine. Kind of like a bird on the wire. But let's say conductor falls down, a couple of poles break, we've got conductor on the ground, it's still energized, and we want it to be energized. That's why we're installing spacer cable, for reliability. So a first responder, a kid or a passerby touches that cable. Well, the first thing they're going to do is they're going to touch it with their foot, right? They're going to touch it with their shoe, and they're going to say, don't really feel anything. They're going to reach over and maybe touch it with a finger or a hand. What are they going to get? Well, let's say, take worst case, it's raining, They got a copper jacket on. They got copper gloves. They're standing in a puddle, completely grounded. Boom, they're going to get that full 1/3 of a milliamp. So I'm going to get a full 1/3 of a milliamp through the body. What's that going to feel like? It's going to feel like somebody hit you in the finger with a sharp pin. And it's going to hurt. It's going to shock you, and you're probably going to let go pretty quickly. Is that a safety hazard? Absolutely, positively, yes. Don't touch energized conductors. Any energized conductor is a safety hazard. Is it a mortal hazard? No. You've got 1/3 of a milliamp. We know that, and we've looked at all the studies on fibrillation. You need 7 milliamps to fibrillate the heart. Other studies say you need 9. Other studies say you need 19. But even with that lower threshold of 7 milliamps, if I can touch 1/3 of a milliamp, I've got 2, 3, 4, 5% of the fibrillation threshold. I'm not going to fibrillate. I'm going to get a shock. I'm going to let go. And if in my right mind, I'm not going to touch it again. So is it dangerous? Is a line down on the ground a safety hazard? Absolutely, positively, yes. Is it a mortal or a fatal safety hazard? No. And again, we're going to be coming out with more information on this sometime in the near future. We're going to be putting out another paper on this exact topic. But please feel free to follow up with me on this. And thank you, David. I will turn it back to my moderator.
Brian, had a couple questions on the EA tech report that you referenced in the UK. So one is they wanted to know if the BLX50 has an ACSR conductor, and do you have a reference for that EA tech report? And do you know of any spacer cable or cover conductor Hendrix projects in the UK?
Gee, those are 3 good questions. I believe the BLX was an ACSR. I can check that, and you can submit this question to me in writing, and I'll answer it in writing. So I believe it was ACSR. Do we have spacer cable or tree wire projects in the UK? We've had them in Europe. We've had them in Scandinavia, Finland, Sweden, Norway, Portugal. I think a couple of other countries on a smaller scale. The Europeans have essentially gone their own way. They relied on us heavily to develop their own standards. The Europeans are still using the standards that we discarded decades ago for weatherproof wire, and that's what their covered conductor standard is based on. Our industry is evolving. We've been involved here in North America with spacer cable for 70 years. They started looking at it 50 years after we did. So they're kind of taking baby steps, if you will, at this point in time. And yes, okay, that study is available and can be found on the net, or it can be gotten through yours truly.
Brian, we have an attendee asking about, do we Hendrix manufacture or support a tap for spacer cable systems that preserves insulation?
Do we have a tap that will serve as insulation?
That preserves the insulation. I believe he's referring to the SciCam insulation piercing.
Yes. Okay, so SciCam came out years ago with their IPC's insulation piercing connectors. Our company went to France to witness the type test for them. We set up a very rigorous schedule of type tests, and SciCam spent a king's ransom getting all these type tests done, and I believe they are approved for 15 kV up to a certain size based on US, ANSI, and ICEA standards. And while it's not our business to promote any connector manufacturers, because you can use any connector you want, I would personally have to say, from a safety standpoint and from an operational standpoint, from an installation standpoint, from a cost standpoint, IPCs have got to be the best thing since sliced bread.
Okay. And Another question, when do you anticipate the 115 cable being available, commercially available? And can you give us an update on where we stand on that? I know we did a pilot project in Maine, so if you could tell us what you learned from that as well.
Yes, no, thank you. Okay, so that pilot project was installed, I want to say late October in 2019. So after 1 year, we had been back several times with a company called Exactor doing partial discharge measurements and disturbance measurements. We found nothing negative. We were there a couple of weeks ago where we partially de-energized it. We partially deconstructed the line. We inspected essentially every square inch of it, took all the components apart, took some of them home, which are in our laboratories right now, and we replaced the components we took. We found nothing negative. We found a couple of things that we might want to fine tune, if you will, but electrically, everything that we wanted in a 115 kV spacer cable system we got. It looks absolutely fantastic. So when will that be available? That will be decided by people of a higher pay grade than myself. But if I was asked as the director of technology to approve it, I would approve it for commercial sale today.
Yeah, and we can definitely provide, as well as these other questions, we can provide follow-up information on that as well. Brian, the final question was, do you have any experience with storm restoration where several poles have been broken? So you've had a major storm and a lot of broken poles. Have you had any experience with that?
Yes, I can say that I have. Yeah, I mean, this is called a cascade failure. Something really bad has happened. The first pole broke, and we happen to have poles that are not robust. They're 20, 30, 40, 50 years old, and a couple of other poles have come down. The only thing it can do is, you know, the number of poles you have, you set that up with a number of buckets, you bring it back up in the air, you replace your poles, you put it back on the new brackets. Yeah, it's a pain. It's time consuming. And, you know, I've got to say, in my 26 years in the company and over 500,000 miles installed, yeah, I've seen it 2 or 3 times. So I guess those numbers, it has happened, but not that many times.
Okay, I think that was all the questions. If you have another one here in the last few minutes, go ahead and submit it. Otherwise, I'll take this moment to tell you that Brian mentioned our other webinar that we have coming in. What was the dates on that, Brian, again? That was December
8th.
Okay, I'm sorry. We had another question come in about the insulation piercing connector, and asking if we're working with any other manufacturers. Not that, to my knowledge, is that correct, Brian? SciCam is the only one that I know that we're working with as far as approving, but doesn't mean that there's not other ones out there. Yes. Do you know of any other manufacturers that run?
I believe that there are other manufacturers of IPCs. I've seen them in Asia. I would imagine that they're still using the thin wall construction standards that they had for low voltage. If we were going to give the green light, we would have to see the type tests, and that those type tests were on IPCs connected to ICEA standard conductor that had the proper insulation walls. I mean, you can't take an IPC for an 80 mil wall and plug it into a 150 mil wall and expect it to work. You're going to have a heck of an arc and a hot spot.
Okay. No, the attendees asking any other American companies, not that I know of, but Brian, you may know of some.
No, but
any other.
No, I don't, but I'm sure they could contact us and submit type tests. And the other thing, Dave, I would imagine if there was an IPC company out there that had IPCs with type tests for ICEA approved conductor, they would have already sent us those type tests.
Gotcha. Okay. Well, we'll go ahead and conclude today's webinar. We really do appreciate, on behalf of Hendrix, we thank you for your time. Hopefully you found it informative and helpful. If you think of any other questions, or you want to follow up on submitted questions, you have Dave Shockley's email address on the screen there. You will get a follow-up package email, as well as a link to a recording of this session that you can rewatch or share with your colleagues or whoever you would like. You can also find your local representative or agent partners on marmonutility.com. So again, thank you very much, Brian. Thank you. And I hope you guys have a great rest of the week.
Thank you, everybody, again. And thank you, Dave.
Thank you.